It's Thursday 25th of August 2022 and welcome to the Water Action Platform, where this month we're talking about how water is related to absolutely everything else. Our programme today has been put together to draw the lines connecting metal recovery to water, carbon emissions to water, the act of moving water to saving building material and even sand to water. I'm excited to speak to Justine Leadbetter from the Water Research Centre about leakage and trees, and we have two great technology showcases that look very different, but both deal with the topic of saving water, saving other raw materials, and saving money, and how they all go hand in hand. Finally, we will reveal who was really on Mars instead of Matt Damon. All of this has been made possible by our wonderful sponsors, shown here. We can view the whole of human development through the lens of the United Nations Sustainable Development Goals. Some of them are very obviously water-related, like 6, clean water and sanitation, and 14, life below water. Some, although less obvious, have been thrown into sharp relief by the COVID-19 pandemic. Water is essential for hygiene and therefore SDG 3, good health and well-being, not only for personal hygiene, but also hand washing and a clean environment, also as a long-term public health monitor and protector. In May, in Action Platform 39, I talked about the rise of SARS-CoV-2 subvariants of Omicron and how their evolution and peak pattern was beginning to look similar to influenza. With influenza, scientists look at the emerging subvariants and use them to design vaccines for each peak flu season. We need a way to do the same thing against COVID-19. Scientists worldwide have been using wastewater surveillance to track SARS-CoV-2, but the methods usually detect only the presence and the amount of virus. That information is used to estimate the rate of transmission in a community, but efforts to identify exactly which subvariants are circulating and predict how prevalent they'll become have been hindered by the low quality of data. New research published just last month demonstrated a wastewater warning system that can also tell us what new subvariants are coming. A team at the University of California in San Diego in the USA developed a new method that uses nanobeads to increase the amount of viral RNA that can be sequenced from a wastewater sample. Previous techniques allowed scientists to sequence no more than 40% of the viral RNA in a sample, whereas the nanobead method enables the researchers to sequence nearly 95%. So not only did they see a peak coming to San Diego 2 weeks before it arrived, but they saw that it was a new variant, Omicron. In November, as you can see on this graph, all cases were caused by Delta, so 1 out of 1 in proportion of all the cases come from the Delta variant, the green area under the graph. By February, Omicron was the cause of all the COVID cases. The blue colour on this graph completely replaced the green. However, the team also developed a tool to identify the subvariants present in each sample and their relative abundance, and that's what we see in the bottom graph. Every colour you see there indicates a different subvariant found. Clinical tests could only tell Delta and Omicron apart, the green and blue on the top graph, whereas the wastewater tool tracked wave after wave after wave of different viruses. All the colours on that bottom graph indicate the proportion of total positive test results caused by each subvariant or each mutation that they detected. So the bottom graph tells us that Omicron subvariant BA.1.1 quickly outcompeted BA.1. Knowing what the direction of travel of SARS-CoV-2 mutation is a valuable piece of information. It helps us predict how many people are likely to be reinfected, how severe their next infection will be, and potentially how to design seasonal vaccines, the way we do against influenza. It's early days, but this tool is likely to help us learn to live with COVID the way we do with flu. Human health also depends on a livable climate, and another nexus is water's relationship with Sustainable Development Goal 13, or climate action. Here, I'm happy to welcome Justine Leadbetter from the Water Research Centre in the UK to talk to us about drinking water leakage and its relationship with climate action.
Thanks, Jo. Hi everyone, I'm Justine Leadbetter, a senior consultant heading up the Leakage and Water Resources team at WRC, a consultancy based in Swindon in the UK. Leakage is a massive problem. Alongside climate change, its impact on water resources led to a challenging target being promoted by the regulator Ofwat in 2019. This target is to halve the level of leakage by 2050 based on the 2018 levels. According to the 3-year leakage average for England and Wales, currently 3,113 megalitres of water is lost each day to leakage. Although there's already been an 145 megalitre reduction, there's still a long way to go. Now, as if that isn't big enough of a challenge already, in 2020 the water industry promised to deliver a net zero water supply to its customers by 2030. Although on the face of it, these two challenges appear very different, they are intrinsically interlinked. This is a list of water companies in England and Wales with their greenhouse gas emissions per megalitre of treated water. The amount of carbon produced to supply water varies by company, from 98 kilograms of CO2 equivalent per megalitre to 309. So if you were to average these, it gives you 193 kilograms of carbon equivalent per megalitre of water. Using this value, that would mean it takes 0.000193 kilograms of CO2 to produce 1 litre of water, which doesn't sound very much. However, if this is scaled up to the England and Wales leakage figure, it equates to 6,800 kilograms of CO2 per day, and a significant amount more per year wasted just due to water loss through leakage. So to put this into perspective, a cow releases around 100 kilograms of methane per year, which is the equivalent to 2,300 kilograms of CO2. So the carbon loss to leakage equates to nearly 100,000 cows, or over 130,000 additional cars on the road each year. To make this number even more shocking, the typical tree can only absorb 21 kilograms of CO2 per year. So currently, nearly 10.5 million trees are required to remove annual emissions lost through leakage. So achieving the leakage target of halving leakage based on 2018 levels, you're looking at a reduction in nearly 5.5 million trees. So we achieve the leakage target, great. Water company resilience has increased and 5.5 million trees have been saved, if only it were that simple. The reality is that all options to reduce leakage will lead to the release of more carbon. Although different types of leakage management will produce various amounts of carbon, all will contribute to the water industry's carbon footprint. Find and fix will contribute through vans, technicians, sensors, batteries and repairs. Asset management through the installation of embedded carbon and pipes. And pressure management again through the embedded carbon, but also through the energy required for control systems. Overall, this is a really complex topic. It's not solely about the level of leakage. There's the water resource impact in terms of the supply and demand balance. There's the economics of leakage, so the cost of the repair versus the cost of the ongoing leak. There's the social and environmental impact, including carbon. And should you consider the impact of reducing leakage for the carbon to be used elsewhere, such as in food production? These issues can only really be resolved if the industry starts to think more holistically and think about how it can implement water, energy and food nexus thinking into the sector and into strategic planning. Thank you very much.
Thank you, Justine, that was fascinating. With the UK as crowded as it is, I don't think you have anywhere to put 5.5 million trees. Clearly you need to move water around without losing it. Holding on to the water we have so we don't waste that embedded carbon and energy that's in it, and moving it from place to place without wasting the water, carbon and energy embedded in the infrastructure we use to move it, relate directly to SDG 11, 13, livable cities and communities. It's also the subject of this month's first technology showcase. We have 2 technology showcases this month, and for this first one, I spoke to Ben Puddy. Ben is a project manager at Hydro International, an engineering company which specialises in water transport and treatment technologies that use first principles of physics and mechanics. One of their inventions is hydro break drop, which takes water from a high level to a low one. It sounds simple, right? I learnt from Ben that it's anything but.
So why is there a need for drop structures? There are many potential hazards when dropping water from height, especially if uncontrolled. Maybe the most obvious one is erosion, because uncontrolled falling water will inevitably erode the surface it falls on. However, there are certain hazards that occur specifically when water drops through pipes or shafts. Uncontrolled air entrainment into a drop pipe can lead to glugging, which in turn may cause hydraulic shock or vibrations within the structure. Another potential hazard in drop pipes is cavitation. This is caused by air bubbles collapsing during uncontrolled high flows, which produces pressure that can damage pipework. Hydrobrake drop eliminates all these risks associated with falling water. Its patented design features control the amount of air within the system, stopping vibration, and dissipates the energy of the falling water to prevent erosion. It is a self-activating system with no moving parts, and therefore requires minimal maintenance. Its unique siphonic operation means it can safely convey flows up to 5,000 litres per second from heights of up to 100 metres. As the water is contained within a drop pipe, maintenance access can be housed within the drop chamber as well, greatly reducing overall construction costs. The integrated maintenance access is a key advantage for hydrobrake drop over traditional drop structures. The problem other structures face is that water drops through the entire shaft, meaning there is no access for maintenance. Therefore, a separate access shaft must be built alongside the drop shaft at much greater cost. The other key difference is that the siphonic operation of hydrobrake drop utilises the head of the entire drop height, maximising flow capacity. The flow capacity of other structures is determined by only the upstream head from the inlet structure, which is far lower. How does hydrobrake drop do it then? Flow enters the inlet structure where it is coalesced before flowing into the drop pipe. During high flows, the water level submerges the inlet pipe, and at this point the air switch entrains air into the system, preventing vibrations or hydraulic shock. When the air switch becomes submerged, the system safely enters full flow capacity. This is due to the siphon effect caused by the air switch and energy dissipation unit both being submerged. The energy dissipation unit at the bottom of the drop pipe dissipates the energy of falling water. It then discharges into a stilling well before topping over a weir to the outlet. Due to the versatility of hydrobrake drop, it can be used across many different applications. This can range from stormwater conveyance to combined sewer systems. In urban areas, we're seeing systems go deeper and deeper, and how the flow drops from source to sewer is vitally important. And even to this day, we're still discovering new applications for this product. The hydrobrake drop units installed for HS2 were the first along a rail network that will safely drop water beneath the track from the top of a rail cutting. Finally, I just want to say we are always open to new ideas and welcome the opportunity to apply hydrobrake drop to any untried sectors our customers can think of.
Thank you, Ben. Sticking with the theme of resource efficiency, we're moving now to our second technology showcase, Floc Opex Recovery, which contributes to SDG 11, Sustainable Cities, and 13, Sustainable Industry and Economic Activity. I had the pleasure of catching up with Molestsane Mophethe, founder of startup MopTech Industries, to find out how they drive their clients towards sustainable behaviours without them necessarily realising it.
Hi folks, I'd like to share with you what we've been developing within MopTech's technology wing over the past few years. The technology is called the Floc Opex Recovery process, which in short we call FOR. Before I get into that and exactly how it works, I would like to share with you a bit about the rationale behind developing FOR. We understand that not all industries' primary focus is environmental sustainability, but more so profitability. We wanted a way to link environmental sustainability to financial returns, and thus add a capitalist flavor to the green engineering framework. As for what it does, well, FOR is a process which allows for the selective recovery of metals from wastewater and sludge. The objective is to reduce volumes of wastewater or sludge which are going to be disposed of and that could have an adverse impact on the environment, but in the process, selectively recover target metals that can be used to increase company revenues, like in the mining operations, for example. In the case of fast-moving consumer goods and the potable water industry, the objective would be to reduce the amount of sludge generated in the flocculation and coagulation stage, and then subsequently recover and recycle the obtained metal flocculants back into the process. Through years of research and experimentation, we found that in general, it's much more cost-effective to recover and recycle these coagulants and flocculants as opposed to purchasing virgin products. Ultimately, money is being saved by reducing the volume of waste that requires disposing of, or even in some cases, neutralizing. But in addition to this, we're focusing on operational expenditure being reduced by recovering and recycling these key metals that are used in the coagulation and flocculation process in the case of FMCG and the municipal water industry. Or perhaps in the mining sector, we're looking at selectively recovering target metals from flotation tailings or from complex wastewaters in order to increase company revenues. How does the process work? Well, the full process is made of a few processing steps, mainly involving leaching, filtration, and ion exchange. Essentially, we start with a waste solution, and through a combination of manipulating variables such as the leaching solution, its pH, the leaching time, as well as particle size, we begin by extracting our metals into solution. Unfortunately, this process is not very selective, as the extraction leaches other undesirable metals and organics into solution, which then leads us to our donor and dialysis stage. Donor and dialysis is essentially an ion exchange process that allows us to selectively recover our target metals. And we do so by manipulating a host of variables, such as, for example, the membranes used, their charge, orientation, the valency size, and concentration of donor ions as well. Once we're happy and we've done this with our recoveries and our selectivity, we then concentrate and recycle the process solution that we've been using through a combination of traditional membrane processes such as nanofiltration and reverse osmosis. Through this full process, we've been selectively able to recover up to 90% of our target metals with a 95% selectivity rate. In short, Floc could serve as a powerful tool whether your company's objective is to reduce its environmental footprint or to recover target metals with the aim of increasing your bottom line.
Thank you, Molestsane. As always, if you want to know more about either of today's showcases, please let me or peers know. Trying to change behaviours can be extremely difficult, and it's one of the reasons why we established the trial reservoir in the first place, to push the industry away from piloting innovations over and over and over again and towards faster uptake. The last time I spoke about the reservoir on a water action platform was in May, and at the time we had 4 trials on the go. We've featured 3 of those trials so far at the times of their launches, and we promised you an update as each trial succeeds. We'll be doing that in a special issue in December for the reservoir's birthday. There are a few more trials underway now. We're aiming for 10 each year and hoping for 7 out of the 10 to conclude successfully. We have 7 underway at the moment to drive the implementation of better, more sustainable technologies and innovations in future. We now come to our Water Action Platform star section, and you may recall this video clip from The Martian and spotted where we flipped from Matt Damon to this month's star.
The problem is water. I have created 126 square meters of soil, but every cubic meter of soil requires 40 liters of water to be farmable.
So I gotta make a lot more water. Good thing is, I know the recipe.
Those who listened carefully to last month's interview by Yang Villa may have recognised that that was the voice of Sid Roy. Sid is an environmental engineer and research scientist who was still only a graduate student when he played an instrumental role in uncovering the Flint water crisis, a situation in which tens of thousands of people were exposed to poisonous levels of lead in their drinking water. An even better quote than the one from The Martian, and one of my all-time favourites, comes from Sid himself, when he made his call to action to all water professionals to pay all advice and help you get forward generously. Sid said, "Answer every message and share information and knowledge so we can all help each other in achieving a common goal." When we recognise people on the Water Action Platform, we don't do a physical award. Instead, our WapWood stars have a tree planted in their name. Sid's tree is a walnut. Just like Sid, it's a young and energetic sapling at the moment, but we confidently expect both Sid and his tree to be even more impressive in future. Our next mystery WapWood star is fully submerged. Listen carefully to the following clip from Finding Nemo and see whether you can recognise this voice.
Hey, Mr. Grumpy Gills.
When life gets you down, you know what you gotta do?
I want to know what you gotta do.
Just keep swimming.
Just keep swimming, just keep swimming, swimming, swimming.
We'll be revealing the mystery star in September. That brings us to our "and finally." Can we store renewable energy with some material other than metal? Energy storage still mostly relies on mined metals like lithium and copper. What if we could make batteries using materials that don't do this kind of damage? Finnish researchers have installed this dull-looking grey silo. It's the world's first fully working dry sand battery, and it's in a district heating system. This could solve the problem of year-round energy supply, which is a major issue for renewable energy. The device is charged up with heat made from wind or solar power. The key element to this device? About 100 tonnes of builder's sand. The sand stores the heat, which can then be used in winter. I went to their website and their case studies and publications to get the technical detail, and this is what it said. They might be slightly oversimplifying things. Let's take a closer look. Low-cost electricity warms the sand up to 500 degrees Celsius by resistive heating, the same process that makes electric fires work. This generates hot air, which is circulated in the sand by means of a heat exchanger. Sand is a very effective medium for storing heat, and it loses very little over time. The developers say that their device can keep the sand at 500 degrees for months. With that, we come to the end of this month's broadcast. I thank all our contributors, our sponsors, and our partners. If you want to know more about any of the topics from today, please let me or peers know. Next month, the Water Action Platform is all about money. Piers is back in the driving seat and he's focusing on investment in the water industry. It will be held on Thursday, the 22nd of September at the usual times, and we hope to see you there. In the meantime, keep asking questions, keep sharing, and keep safe.